Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we will study the serial communication in 8051 microcontroller. We will start with what is the serial communication, what are the types of serial communication, and then we will study the registers which are used for serial communication in 8051 microcontroller. So let us start with our topic. The 8051 microcontroller, it can send or receive the data from the outside world. This outside world for the microcontroller, these are the input-output devices. So from the input-output devices, it can receive the data also and it can send the data also. So what is this this transmission of data from the microcontroller to the input-output devices? Okay, that is called communication. So we can say that communication is nothing but it is the transmission of data. This transmission, it can involve the receiving of data also and sending the data also. Okay. So microcontroller, it can send the data to the peripheral devices also and it can receive the data also from the peripheral devices. And this sending and receiving, or we can say this transmission of data, it is called the communication. Now here we are studying the serial communication in the 8051 microcontroller. So here we will consider the microcontroller as the 8051. This is the most popular and the commonly used general purpose microcontroller. It was the first microcontroller which was developed. So this 8051 microcontroller, it is an 8-bit microcontroller. And also this microcontroller, it is a parallel device. First let's come to the communication here. So communication, we told that it is nothing but is the transfer of data between the microcontroller and the peripheral devices. Now this communication, it can be of two types, that is serial communication and parallel communication. Now when the data is transmitted, the data it is in the form of bits, that is 0 and 1. So when the bits are transmitted one by one, then it is called serial communication, and when all the bits are transmitted at the same time, then it is called parallel communication. So serial communication means all one bit at a time, whereas in parallel all bits are simultaneously transmitted. So when one by one the bits are transmitted, that type of communication is called serial communication, and when all bits are transmitted simultaneously, that will be called parallel communication, or we can say transmission. Now here one bit is involved, so only single line is there. Single line is used for the transmission of data, and here because all the bits are to be transmitted, and if we are having a device which is transmitting 8-bit of data, so we will require that many number of lines. So here many number of lines are required for the transmission of data. Now as we are studying here the 8051 microcontroller, so 8051 microcontroller, it is an 8-bit parallel device, means it is dealing with an 8-bit data, okay, all So all the data that will be in the form of parallel, okay, means 8 bits of the data it is considered as a whole, okay. So parallel device means internally it is dealing with the parallel data, that is 8 bits at a time, okay. Now when this microcontroller it is transmitting the data to some peripheral device, so inside it has 8-bit data, that is parallel data. So for parallel transmission it will require 8 lines, and those 8 lines will transmit the data to the peripheral device. Now suppose that the peripheral device it is located at some remote location, means at a very long distance from the microcontroller. So those 8 lines we have to make those lines available to whole distance, means over a long distance we have to make available those 8 lines, okay. So that becomes a very hardware problem will be there, because circuitry increased for those 8 lines. Whereas if we use the serial communication, in those cases we have to use only one line, okay, for the transmission of data. So for long distance communication always serial communication is preferred, because here we require only a single line, whereas in parallel we will require many number of lines, okay. So microcontroller it is dealing with the parallel data. For communication over long distances it has to convert it into the serial data. So parallel to serial conversion has to take place. Now again this peripheral device it is also a parallel device, it will also deal with the parallel data. So it is receiving serial data from this microcontroller, it will convert it into parallel data, means serial to parallel conversion has to take place, and then that parallel data will be processed by the peripheral device. So at this place the parallel to serial conversion is taking place, then serial data is transmitted, and here serial to parallel conversion is taking place. So whenever we study the communication or transmission of data over long distances, we use serial communication. So here in this video, we will study the serial communication in 8051 microcontroller. First, we will start the basics. We will start with the basics of the serial communication. So first we will study that what are the various types of communication links. Means how the microcontroller and the peripheral device they can be linked, or we can say the sender and the receiver. Okay, sender we can say the transmitter which is transmitting the data, and receiver which is receiving the data. So how the transmitter and the receiver they are linked with each other. So first we will study the types of serial communication links. In this we have 3 types of communication links. First is the simplex, second is half duplex, and third is full duplex. So these are the 3 types of serial communication links, that is in these 3 ways the transmitter and receiver they can be linked with each other. In simplex, suppose this is the transmitter, this is the receiver. So in simplex communication link, the transmitter is going to transmit the data and receiver is going to receive the data. So here we will have only a single line. And single line is there, transmitter is going to transmit data, sending the data, and receiver is going to receive the data. So in simplex the transmitter is always transmitting and receiver is always receiving. No back command is generated. If we talk about an example, so like computers and printers. So computer, it gives the command to the printer that you have to print this document. Printer cannot give back the commands to the computers. Okay, so computer is always giving the command and printer is always printing the document. So that is an example of simplex communication link. In half duplex, this is the transmitter, this is the receiver. Now here also we have only a single line. Transmitter is going to transmit the data to the receiver, but this receiver, it can also send back the data to the transmitter. So this transmitter is acting as receiver also and transmitter also. Also this receiver, it can act as transmitter also. But here we have only a single line. So this single line, it can be used for sending the data from 1 to 2 and also from 2 to 1. That means only single function can be performed by this single transmission line. Or we can say it can act, it can be used for either transmission or reception. But only one direction at a time. At a time, it can act in one direction only, either from 1 to 2 or from 2 to 1. So that is a kind of half duplex. Whereas in full duplex, it can act in both the directions simultaneously. We have two lines, from transmitter to receiver and from receiver to transmitter. In both the directions, it can work simultaneously. It can send the data from 1 to 2 also and from 2 to 1 also. So that will be the full duplex. Transmitter, this is the receiver, this is receiver also and transmitter also. So transmitter to receiver, it can also act, and from 1 to 2 and 2 to 1, it can act in both the directions. So that is the case of full duplex. So the difference between full duplex and half duplex is that it is only one direction at a time, but here in both the direction at the same time it can work. So these are the three types of communication, serial communication links. Okay, simplex, half duplex and full duplex. Now let's come to the types of serial communication. Now when communication, that is transmission of data, is done between microcontrollers and the peripheral device, suppose microcontroller is sending the data to peripheral device, how the peripheral device is going to know that the data is completely transmitted, and how the microcontroller is going to check that the peripheral device capacity has been full, now it cannot receive many data, means after its capacity is being full, now it is not able to receive more data. Okay, so how these conditions are satisfied, depending upon that we have the various types of serial communication. Here we have two types, synchronous and asynchronous. In synchronous serial communication, the transmitter and the receiver, they are synchronized with each other. Means this synchronization is done with the help of the clock pulses. Okay, so the transmitter and receiver, they are going to share the same clock. So whatever at the time, suppose at after 1 second this transmitter is sending the data, at the same time the receiver is receiving the data. So the working of transmitter and receiver, they are synchronized with each other with the help of the same clock which is shared by them. So that type of serial communication is called the synchronous serial communication, okay, in which the two transmitter and receiver, they are synchronized. Whereas when both transmitter and receiver, they are not synchronized, it is called the asynchronous serial communication. In that case, transmitter will have a separate clock, receiver will have a separate clock, okay. So for the receiving and transmitting the data, like the transmitter is sending the data, how receiver will get to know that this is the starting point and this is the ending point. Along with the data, we will send some bits, and through those bits the receiver is going to get an indication that this is the starting point and this is the ending point of the data. So that is the case of asynchronous serial communication. Whereas in the synchronous, because they are sharing the same clock, so there is no need to send the information, it is contained with the data itself. It is synchronized with the clock, that when the clock pulse changes from low to high or from high to low, at that time I am going to send the transmitter is going to send the data and receiver is going to receive the data. So this types of serial communication, we have two types, synchronous and asynchronous. So the differences, if we talk about between synchronous and asynchronous, so in synchronous serial communication, we have the transmitter and receiver, they are synchronized, whereas in asynchronous, they are not synchronized. In synchronous, they share a common clock, whereas in asynchronous, transmitter and receiver, they are going to have the separate clock for them. In synchronous, first the sync character is sent and then the data is sent, whereas in asynchronous, start bit is set, then data is sent, and then stop bit is sent. Now in synchronous, we send block of data. Means blocks of data is transmitted at a time, whereas in asynchronous, single bit is transmitted at a time. So these are the differences. Now if we represent it diagrammatically, this is the transmitter, receiver, they are sharing a same clock here, and we have the data, and in that data first we will have the sync character and then we will have the data. So this is the type of synchronous serial communication. In asynchronous, we will have transmitter and receiver with their separate clock. Transmitter will have its own clock and receiver will also have its own clock. And if we talk about the data, so in data we will have the 8-bit of data, but in starting we will have a start bit, and in the last we will have a stop bit. Now along with this stop bit, we have a parity bit also to check the parity when the data is received by the receiver. So this is the type of asynchronous serial communication. Okay. So we studied about the types of serial communication, asynchronous and synchronous. Now when we study the serial communication, we often encounter with a term which is called the baud rate. Okay. So what is this baud rate? This baud rate means it is also called the transfer rate, and it means bits transmitted per second. Okay, means how many bits are transmitted per second, that will be called the baud rate or the transfer rate. Now in serial communication we were having the two types, asynchronous and synchronous. Now in asynchronous we studied that only one bit is transmitted at a time. So there is no need to calculate the baud rate because only one bit is transmitting per second. So that will be equal to the baud rate. We can easily calculate the baud rate in asynchronous. In synchronous, because blocks of data is transmitted, and in that block of data we will have many number of bits. So in that case we need to calculate the baud rate. Let's take an example. Suppose that 9600 baud of data is transmitted. Okay, means 9600 bits are transmitted in 1 second. Okay. This is the baud rate. So how many if we want to calculate the bit transmission rate, so 1 second divided by 9600, that will be equal to 0.104 millisecond. Because here in 1 second 9600 bits are transmitted. So one bit, if we want to calculate that what time will be taken to transmit one bit, it will be 0.104 milliseconds. So in this way, using the baud rate, we can calculate that how many bits are transmitted per second. Also we can calculate that how much time is taken to transmit one bit. Okay, so this is the term called the baud rate. Now let's come to the serial communication in the 8051 microcontroller. Now 8051 microcontroller, it supports full duplex serial port. Okay, means it has different ports in 8051. Those ports, they support serial communication, and the type of communication link is full duplex, means transmission and reception of data, it can take place at the same time. Okay, so we can say it supports Now in 8051 microcontroller, we have three special function registers which are used for serial communication. So here we will study those three special function registers. They are, first is the SBUF register. Second, we have SCON register. And third, we have PCON register. So these three registers are used by 8051 for serial communication. SBUF is the serial buffer. SCON is serial control. And PCON, P is for power and CON is for control. So these three are the special function registers in 8051. We will study these registers in detail. First we will start with SBUF. Okay, now for serial communication we have both transmission and reception. So it has to transmit 8-bit data also, and it has to receive 8-bit data also. So at the time of transmission it is going to store that data, 8-bit data, into a buffer. Buffer is used for the storage of data, so that buffer is called the serial buffer. Okay, so at the time of transmission the 8-bit data will be stored in the SBUF register, and at the time of reception of data, means receiving the data, that received data will be first stored in the SBUF register. So this register is used for both transmission and the reception. It is an 8-bit register. So this is an 8-bit register. It is going to hold the 8-bit data, and we have separate S buffer, serial buffer registers for the data transmission and for data reception. For data transmission, the data which is going to be transmitted, it will be transmitted via the TXD line. Okay, so before the transmission it will be first stored in the SBUF register, and when the data it is received, so first it will be received in the it will be received through the RxD pin of the microcontroller, and then it will be stored in the SBUF receiver register. Okay, and then it will be read by the microcontroller. So it is used for both transmission and for the reception. Next we have the SCON register, that is serial control. This register is also an 8-bit register, and it is used for different purpose. Because this register is having 8 bits, so each bit is having some functions associated with it. Like it can be used for mode selection bits also. It contains mode selection bits. So this SCON register, it is used for all these purposes. That is for the mode selection, that in which mode all the serial ports they are going to act, and also for the serial port interrupt bits, that is TI and RI, and the 9th data bit for the transmission and reception. So let's see the 8 bits of this SCON register. So these are the 8 bits of the SCON register. In these 8 bits, starting from D0 to D7, D0 is the least significant bit and D7 is the most significant bit. So SM0, SM1, SM2, these are for the mode selection. Then we have REN, TB8, TB8, these are the 9th data bit for the transmission and reception, and TI, RI, these are the serial port interrupts. So let's study the SM0, SM1, how these 2 bits are used for the mode selection. Now, because these are the 2 bits, so they can take any value like 0, 0, 0, 1, 1, 0 and 1, 1. So in the serial modes, we have 4 modes, mode 0, mode 1, mode 2 and mode 3. So if these 2 bits are 0, 0, then mode 0 is selected. If it is 0, 1, then mode 1. If it is 1, 0, then mode 2. and if it is 1 1 then mode 3. Okay, so how these two bits are used for the mode selection we can see here. Now mode 0, it is also known as the 8-bit shift register mode. Mode 1 is known as 8-bit universal asynchronous receiver transmitter. Okay, then mode 2 is known as 9-bit UART, and third mode is also the 9-bit universal asynchronous receiver transmitter. So these are the names of all the 4 modes of the serial ports. Then we have SM2. This is the multiprocessor communication bit. So this SM2 bit in the SCON register, this bit is used for the multiprocessor communication. When the serial ports, they are in mode 2, that is the 9-bit UART mode. So in this mode, if this bit is set, SM2 is set, then it is going to enable the multiprocessor communication mode. Okay, so this is the use of SM2. Next bit we have is REN, that is receiver enable. Because both transmission and reception can take place in 8051, so to enable the serial reception we are going to make this bit 1. So when it is 1, it is the serial reception will start. Next bit we'll have is the TB8 and TB and we have RB8. So these bits, they act as the 9th bit for the transmission and reception of data. When 8-bit of data is transmitted, so along with that 8-bit we have start and the stop bits also. Okay, so those bits, that is the 9th bit of that data, that is the TB8 and RB8 during the transmission and reception. Now as we studied the mode 2 and mode 3, they are the 9-bit UART mode. So here this 9th bit during the transmission and reception, that is given by the D3 and D2. So it is the 9th bit that is transmitted in mode 2 and 3, and RB8 is the 9th bit that is received in mode 2 and 3. Next bit we have is D1 and D0, that is TI and RI. So this is the transmit interrupt flag and this is the receiver interrupt flag. So these are the interrupt flags. These flags, they can be set and reset. So setting of these flags is done by the hardware and resetting means clearing of these flags is done by the software means. So when these bits are 0, the interrupt flags, they are reset. Okay, and if we want to set these flags, then hardware means are used. So this is the description of all the 8 bits of this SCON register. We studied that these 2 bits, these are used for the mode selection. Then for serial port interrupt, we have TI and RI. For the 9th data bit of reception, we have TB8 and RB8, and this is to enable the serial reception. Next special function register we have is the PCON register, that is the power control register. This register is also an 8-bit register. This register is however used for controlling the power of 8051 microcontroller, but there is one bit in this register which is used for serial communication also. Let's study about it. PCON register. So in this PCON register, the 8 bits from D7 to D0, they are described like this. D7 is for the serial mode. Okay, so this is used to use the, because in serial communication we have the baud rate here. Okay, so this is used to serial rate modify bit. It is used for the baud rate selection in the different modes of the serial ports, like mode 0 to mode 3. This bit is used for the baud rate selection. Like if it is set, means if its value is 1, so when this bit, it can be set to 1 or it can be set to 0. So when this bit is 1, it means the baud rate will be double the baud rate using the timer 1 in mode 1, 2 and 3. Whereas when this bit is set to 0, then the baud rate will be equal to the timer 1 baud rate. So this is how the baud rate is selected using the SMOD bit. The rest of the bits of this PCON register, they are not used in the serial communication. D6, D5, D4, they are reserved for future use. GF1 and GF0, these are the general purpose flag 0 and 1. PD is for the power down bit, means if we want to reduce the power supply to the microcontroller, then we can use this bit PD. And IDL, this is for the idle mode selection, means if we want to set the microcontroller in the idle mode, then this bit can be set. Okay, so rest are not used for the serial communication. Only there is one bit, that is D7 bit, which is used for the serial communication for the baud rate selection. So this is the PCON register. So the three special function registers used in serial communication are serial buffer SBUF, then SCON serial control, and PCON, that is power control. Now in the SCON register, we studied that the first two bits, that is SM0 and SM1, D7 and D6, they are used for the mode selection. And we have 4 modes, serial communication modes in 8051, mode 0, mode 1, mode 2 and mode 3. So let us study these 4 modes. So first mode we have is mode 0, which is also known as the 8-bit shift register mode. Now in this mode, the serial port, it will run in the synchronous mode. That means synchronous serial communication will be used. Along with the data, we will send a sync character, and 2 signals are required. One signal will be the data signal and second signal will be the clock signal. So the transitions of the clock pulse, that is from low to high and from high to low, so those transmissions are going to decide that when the data will be transmitted and when it will be received. Okay, so in this we will require 2 signal, clock signal and the data signal. Data is transmitted and received through the RxD pin. We have 2 pins here. and another pin is the TXD pin. So TXD pin is used for the clock signal. If we talk about the baud rate, so in this mode 0, the baud rate will be equal to 1 by 12 of the clock frequency. So in mode 0, we will have only an 8-bit data. That 8-bit data will be transmitted or it can be received through the RxD pin. Along with the data, we will have a clock signal. That clock signal will be transmitted through this TXD pin. Okay, and the baud rate for the transmission will be 1 by 12 of the clock frequency. So it is a type of synchronous transmission and reception. Next we have mode 1, which is called the 8-bit UART. UART means universal asynchronous receiver and transmitter, means it is acting as receiver also and transmitter also. 8-bit data we have here, so that 8-bit data will be stored when in the case of transmission it will be stored in the serial buffer register, and at the time of reception also it will be stored in the serial buffer register for the receiver. So this in mode 1, because it is an 8-bit universal receiving and transmitting is done here, and in this we have a serial buffer which is used for storing the data. Now in this we have the 10 bits of data, means along with that 8-bit we have one start bit and one stop bit. So it is an asynchronous serial transmission. 10 bits are there. Also, it is full duplex transceiver, means transmission and receiving can be done at the same time. Okay. Now, in this we have TI and RI, that is transmitter interrupt flag and receiver interrupt flag. These TI and RI, they will be set once the transmission and reception of the data it is over. And if we want to reset then we can use the SCON register. Okay, and in this mode 1 the baud rate is variable, it can be changed. How we can calculate this baud rate? We have the formulas, that is twice of this SMOD bit, means SMOD bit from the PCON register, D7 bit. Okay, so 2 into that SMOD divided by 32, okay, into the timer 1 overflow flag. What will be the status of that overflow flag? That will be here. Okay, so through this formula we can calculate the baud rate. Also we have twice of SMOD into 32 into the oscillator clock frequency divided by 12 into 256 minus the timer 1 overflow flag. Okay, so this baud rate is calculated, it is determined with respect to the status of the timer 1 overflow flag. That is why we can say that in mode 1 the baud rate is variable. Okay, whereas in mode 0 it is fixed. Okay, next we have mode 2. Now the difference between mode 2 and mode 1 is that it is also an a UART, that is universal asynchronous reception and transmission, both is done and in the asynchronous mode only. The difference is that in the mode 1 we have only the 10 bits, whereas in mode 2 we have total 11 bits. Okay, 11 bits are transmitted or received. One is the start bit, 8 bits are for the data, and 2 are the stop bit. Now out of these 2 stop bit, one is the programmable ninth data bit. Okay, this ninth bit, as we have studied in the SCON register, the TB8 and RB8, that is the at the time of transmission and reception, the ninth bit will be available from the SCON register. So this ninth bit along with these 8 data bits plus 1 start bit and 1 stop bit, so total 11 bits are transmitted or received in the mode 2. If we talk about the baud rate, so in the mode 2, the baud rate is equal to the twice of S mode divided by 64 into the oscillator clock frequency. Now this S mod bit, it can be 0 or it can be 1. So we can say that in mode 2 the baud rate is 1 by 64 of the clock frequency, whereas in mode 1 it was 1 by 32 of the clock frequency. Next comes the mode 3. Mode 3 is similar to mode 2. In mode 3 also we have the 11 bits, 1 start bit, 8 data bits and 1 programmable 9th data bit and 1 stop bit. Okay, but the baud rate, it is not similar. The baud rate is calculated by the formula which we studied in mode 1, that is using the timer 1 overflow flag. So baud rate is similar to, or we can say is calculated as mode 1, otherwise it is similar to mode 2. Okay, so these are the 4 modes, 4 serial communication modes in 8051 microcontroller. Mode 0 was 8-bit serial shift register only, it was synchronous type mode. Mode 1, 2 and 3, they are of asynchronous type, in which the baud rate is either variable or it can be calculated by the formulas. Okay, so in this video we studied about the serial communication in 8051 microcontroller. First we studied that what is the serial communication, what are the types of serial communication links, then types of serial communication, asynchronous and synchronous. Then we studied the 3 special function registers, SBUF, SCON and PCON, and in the last we studied the serial communication modes of 8051. So I hope that this topic is clear to you. Thank you.